For the last couple of years, if you wanted to build an effective retrieval augmented generation system, a RAG system,
Yeah.
you're basically signing up for weeks of heavy lifting on the infrastructure side.
Oh, absolutely. It was all about wiring up custom pieces, managing vector databases. I mean, just trying to keep that whole retrieval stack working before you even got to the user prompt.
Right. It felt like architecture first, application way, way second.
Totally. RAG was this big infrastructure bet, and frankly, it came with a lot of background anxiety, Costs, complexity. Teams spent so much time on the plumbing.
Plumbing is the perfect word. Chunking strategies, ingestion pipelines, worrying about vector index shards.
More time on that than on, the actual quality of the answer sometimes.
But this article we're looking at today by Azmat, it suggests that whole paradigm might be well over. It introduces the new Gemini File Search tool, promising grounded answers from your own documents, potentially in a single afternoon.
And that's the shift, right? That's what we need to unpack for you today. How does this tool actually deliver on that simplicity? What specific burdens does it lift?
And what does this mean strategically for, anyone needing accurate AI answers grounded in their own knowledge?
Exactly. Our goal here is to break that down, understand the how and the so what behind this change.
We want to respect your time, give you the shortcut to grasping this pretty significant technological shift. So let's dive in.
Let's do it.
Okay, so starting right at the core, what is Gemini File Search fundamentally? Is it just hiding the complexity, or is it really getting rid of it?
That's the key question, and I'd say it's doing much more than hiding. Think of it as a fully managed RAG service, built directly into the Gemini API itself.
Okay.
The big change here is the level of abstraction. It essentially removes the need for you, the user, to custom manage 4 really key parts of that traditional RAG pipeline.
All right, let's zero in on those 4, because understanding what's being abstracted away really tells us what pain points are disappearing. So what's the first piece of that ingestion process it handles?
The first is automated chunking. So instead of you writing custom code to split up your PDFs or your docs,
Which can be surprisingly tricky.
it can be. The service uses sensible defaults to do that splitting. Now, you can tune it, but for most people, it just takes care of that initial, often painful step of breaking down long documents into embeddable chunks.
Okay, that's chunking. What's the second pain point it tackles? The one that often needed its own API key in billing?
Yeah, that would be the built-in embeddings. It uses Google's own embedding models automatically, seamlessly.
Meaning?
Meaning you're not making separate calls to an embedding service, you're not managing keys for it, you're not paying separately for that vectorization step. It just happens, streamlines things quite a bit.
Okay, number 3. This one honestly used to cause major headaches for infrastructure teams. Managed vector storage. What does managed really mean here? Is it just a hosted database?
It means zero infrastructure management overhead for you, none. You don't need to figure out how big a cluster you need. You don't worry about sharding indexes. You don't monitor storage usage constantly.
Wow.
That entire layer of complexity, which is often expensive too, it's just absorbed by the service. For a lot of teams, that alone is weeks of planning just gone.
Okay, so documents are chunked, embedded, stored,
Yeah.
all managed. What's the final critical step in the RAG process that the service handles?
That's the seamless retrieval. So the tool takes the user's question, it figures out which chunks from your stored documents are most relevant.
Right.
Automatically injects those relevant chunks into the prompt for the generation model, and then gives you back the final answer grounded in your docs and, crucially, with citations.
Without needing something like LangChain to manually connect all those dots.
Exactly. It completes that whole chain internally. No need for an external orchestration framework just to make the basic RAG flow work.
So when you put those 4 things together, automated chunking, built-in embeddings, managed storage, seamless retrieval.
Yeah. For teams just wanting an internal knowledge base or something similar quickly, this really does make RAG feel like, as the article puts it, a practical default, not some massive science project.
Precisely. It lowers the barrier to entry dramatically.
Okay, let's shift gears slightly because the article makes a strong point about the pricing. It suggests the cost model itself is designed to change how teams approach this. How does it get rid of that background anxiety about costs?
This is, I think, really interesting and genuinely behavior-changing. The pricing is structured for experimentation and easy scaling. 3 key things here.
Okay.
First, indexing. That's when you upload your documents. It's a low one-time charge, about 0.15 per million tokens. So predictable upfront cost.
Okay, that's for converting the docs into vectors. Makes sense.
Exactly. But here's the kicker, the part that really flips the usual Argo-Koth model on its head. Storage is free.
Wait, free. Storing all those vectors is free. Free. And the query time embeddings are free too. So when a user asks a question, creating the vector for that question to do the search, also free.
Hold on. Free storage and free query embeddings. That just evaporates the need for vector database capacity planning, doesn't it? What if you want to index millions of documents?
It means you can. You can scale your knowledge base pretty aggressively without this huge ticking meter of infrastructure costs just to hold the index.
Okay.
You only pay when the system actually retrieves relevant context chunks.
Okay.
And uses those tokens in the final prompt to generate the answer. And those are just billed as standard context tokens within Gemini.
I see. So you pay for the value, the generated answer, not the infrastructure sitting idle.
Exactly. The article points out this makes file search probably the simplest vector database alternative if your main goals are predictable costs and just getting value quickly. It's cost neutral until it's actually useful.
Yeah, that's very compelling economically. Okay, so let's make it practical. The article outlines a quick workflow. Can we walk through the main steps just so listeners get the mental model?
Sure, it's designed to be straightforward.
Step 1 seems to be create a file search store. You basically set up a container, like a project-level index for your specific documents.
Right, think of it as your dedicated knowledge space.
Step 2, upload and index a document. You push your files, PDFs, code, whatever, through the API, and the service just handles the chunking, embedding, indexing automatically, like we discussed.
Yep, the magic happens behind the scenes there.
And then step 3 is where you actually use it. Ask questions and return citations. You tell the Gemini model, hey, use this store as a tool to help answer the question.
And that's the core loop. Create a store, add docs, ask questions that use the store.
Now, the article puts a lot of emphasis on user experience here, specifically on citations and candor. Why is candor so important for this kind of Q&A?
Oh, it's absolutely critical for trust. First, a RAG needs to show its work. It has to provide those citations, those links back to the source document so you can verify the answer. Receipts, basically.
Makes sense.
But candor is maybe even more important. If the system can't find a relevant chunk in your documents to answer the question, it needs to say so. It needs to admit, I couldn't find that in the provided files, rather than guessing, or worse, hallucinating an answer.
Right, because a confident wrong answer is worse than no answer.
Exactly. That transparency, admitting when it doesn't know, is what builds user trust, especially in like an enterprise setting.
That trust piece is huge. Okay, so the defaults are designed to be easy and useful, but developers, they always want more control. The article says control is better when you need precision. So how can you tune this beyond the defaults?
Right, and they do provide levers for that. Two main advanced features stand out for really tailoring the quality. The first is managing chunking trade-offs.
So you can override the automatic chunking?
You can influence it. You can set two key parameters, the maximum tokens per chunk, so how big each piece is, and the overlap between consecutive chunks.
And why would you adjust those? Is it just about document length?
It's more about the type of content and the kinds of questions you expect. For example, if you're indexing really dense stuff like API documentation or troubleshooting steps, you probably want shorter chunks, maybe like 220 tokens with just 24 tokens overlap. That helps pinpoint very specific facts accurately.
Okay.
But if you're indexing, say, legal contracts or long narrative reports where context flow is crucial, you might want larger chunks. Bigger chunks help maintain that continuity across paragraphs, even if you lose a tiny bit of pinpoint precision.
So it's a trade-off you need to test based on your specific use case and measure the results.
Exactly. It requires thinking about the end-to-end quality, not just retrieval speed.
Got it. What's the second advanced feature? Metadata filters. That sounds potentially really powerful, especially for bigger organizations.
Oh, it is. It's transformative for managing knowledge at scale. When you upload a file, you can attach descriptive tags, metadata. Things like domain finance or status approved or version 3.
Okay, simple key value pairs.
Right. And then when you ask a question, you can add a filter to the query. You can say, only search documents where metadata filter, domain security, and status approved, for example.
So it acts like a bouncer,
Yeah.
only letting relevant documents into the search party.
Precisely. It turns what could become one massive, potentially diluted index into a set of focused, scoped views. Think about it. If your legal team, your support team, and your engineers all share one big store.
Yeah, you don't want legal jargon popping up in an engineering answer.
Exactly. Filters keep the responses crisp, relevant, and specific to the context of the query, even within a shared knowledge base.
That makes a lot of sense. Okay, let's zoom out a bit. Thinking about the whole ecosystem.
Hmm.
When would you choose this managed service, Gemini File Search, versus building or sticking with a custom RAG stack? The traditional approach with LangChain and a dedicated vector DB.
The article draws a pretty clear line based on the trade-offs, mostly around control and complexity.
Okay.
Gemini File Search is optimized for speed, simplicity, and predictable cost. Setup is minutes, not weeks. Costs are low. You get, let's call it, moderate control. It's presented as the go-to for internal knowledge bases, documentation Q&A, product manuals, the common stuff.
And the custom stack.
Yeah.
The LangChain plus vector DB route.
That's for when you need high control. Setup takes days, maybe weeks. Costs are higher, less predictable because you're managing the underlying infrastructure. You go this route if you have what the article calls exotic control requirements.
Exotic control, like what?
Like needing to bring your own custom fine-tuned embedding model, which File Search doesn't allow. Or if you need to build really complex multi-step agent workflows with specialized routing or maybe hybrid search logic that the managed service just doesn't offer out of the box.
So the message seems to be, start simple with the managed service and only take on the complexity of a custom build if you hit a hard requirement that demands it.
That's definitely the suggested pathway. Start with File Search, get to production fast. If down the line your needs evolve and you realize, okay, we absolutely need this custom pre-processing step, or we must use our own embedding model, then you can graduate parts of the stack, as the article says. Build custom only when you have to. Saves a ton of engineering effort up front.
Makes sense. Now, any tool, especially one abstracting this much, will have limitations. The article calls them guardrails. What are the key boundaries people need to be aware of?
Yeah, knowing the limits is crucial. The first big one, which we just touched on, is you cannot bring a custom embedding model. You're using the Google-managed ones, period.
And that's a significant trade-off for some, right? Especially in niche domains.
Absolutely. If you're in a highly specialized field medicine, specific areas of finance where custom-tuned embeddings on your proprietary jargon make a huge difference, giving that up for simplicity is a major strategic choice.
Okay, what else? Any limits on getting data in?
Yes, the upload process is explicit. You have to push specific files via the API. There's no built-in crawler to just point it at a website or a shared drive and say, index everything. You control the knowledge boundary explicitly.
Got it. And the chunking we talked about earlier.
While you can tune size and overlap, the chunking itself is practical, not exotic. It doesn't have super sophisticated features like understanding complex document layouts or tables perfectly. It's good, solid chunking based on size and overlap. But for really irregular documents, you might still need some pre-processing on your end.
Fair enough. And what about scale? Even managed services have limits.
Correct. There are standard store size and rate limits. The advice in the source is to think about splitting your knowledge proactively, maybe by domain or product area. Keep individual stores reasonably sized to maintain good performance and latency. Don't just dump everything into one giant store.
Okay, that seems like sensible advice. This naturally leads to the big question the article kind of tackles head on.
Yeah.
Is this thing a vector database killer?
Yeah, the million-dollar question. The short answer from the article, and I think it's right, is no.
Why not?
Because dedicated vector databases do a lot more than just power RAG. They're used for pure similarity search, recommendations, data analysis, applications far beyond just grounding LLM answers. So VDBs as a category aren't going anywhere.
Right,
But for that specific, increasingly common job of light to medium error use cases, this changes the game. By making storage and query embeddings effectively free, it removes the need for a separate dedicated vector database for many, many teams. It basically pulls RAG infrastructure into the core LLM service itself. And that is going to put enormous pressure on the VDP market, especially on pricing and ease of use for RAG.
So not a killer, but definitely disruptive for that slice of the market.
Very disruptive, yes.
Okay, pulling it all together. The big picture takeaway from the article seems to be that the AI community spent, 2 years really wrestling with the plumbing of RAG, getting the basic architecture right.
Yeah, a huge amount of effort went into just making it work reliably.
And now services like this provide that baseline infrastructure. So where should developers and knowledge engineers be focusing their energy now?
The focus shifts dramatically. It moves from the architecture, the plumbing, to the craft.
The craft.
Yeah, better document hygiene, making sure your source material is clean and well-structured. Crafting better prompts, more specific prompts, designing better questions for the end-user application. You can stop worrying about tuning the database cluster.
And start worrying about the actual quality and relevance of the answer.
Precisely. Elevating the quality of the interaction now that the foundation is solid and managed.
The article's closing advice seems like a really practical next step for anyone listening.
It really does. It basically encourages you to just try it. The final thought for you, the listener, is this challenge. Create a store. Upload one document that your team keeps asking about. Ask 3 real questions and read the citations out loud.
Test it on a real problem.
Exactly. See if it works for you. If the service earns trust, grow it. Start small, validate, then scale.
And if this tool genuinely replaces weeks of that infrastructure busy work for grounded Q&A, the amount of engineering time saved is potentially huge.
Massive. So the final provocative thought, building on the article's close, is this. If this core RAG infrastructure is becoming a solved problem, something you can deploy in an afternoon, what are you going to build with all that time you just saved? What's the next layer of value you can create?